maybe. I need to plug this in, that's the problem. There we go. Alright, so, in our notes, we'll title this is the last section, 1.8, I guess, and it is parameter and area. Whoa, that is really big.
Oh, you remember Josh was drawing on you yesterday?
What a little bonobo. Okay, so perimeter and area. Let's get some definitions for these down, and we'll mainly focus on boxes and circles. Those are some easy ones. So let's get some definitions down here. What is perimeter? Anyone remember?
All the sides added together.
Okay, distance around. And Coleman is correct also. Not only is it distance around, but it is, we find it by basically adding the sides. And our formulas will give us shortcuts to get that really quick. Whereas area, anyone have a way to put area? What might we define area as?
The inside.
How much space it takes though.
Okay.
Like acres.
Space on the inside.
Space on the inside. We want to be careful of that. That's a good definition, but we want to be careful when in geometry when we talk about space, we usually are talking about a three-dimensional thing. Like right now, we are inside of a space. But there really is no other way. We could say that it is the flat space, there we go, on the inside of a shape. So just to get a few simple ones out of the way, like we have that's supposed to be a straight line, so we have a box right here. Well, I could have just used the box tool right there. But let's say that we have something like this. So we have 3 units right here, whatever they are, and we have 4 units right here, whatever they are, centimeters, inches, it doesn't really matter. But let's say I wanted the perimeter and the area of this. Now one way to count the area would be to just count the number of boxes. And that's how we talk about area usually, is the number of unit boxes or squares inside the shape. So we could count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you know from previous years of having done some level of geometry that would not be a very efficient method to find the area. But we could do that. But there's a faster way. Area of a box, I'll put a little box next to it so we have that, is the base times the height, where the base, and notice this symbol, so we're going to be using a lot of symbols this year, is perpendicular to the height. They have to form a right angle. Don't be using any slanted heights. They form a right angle. So using this formula, I would do area of the box is base has a length of 4 times the height, which is length of 3, which is the 12 that we got. 12. Easy. Base times height.
Why does it look so weird now?
Okay, anyways, let's talk about perimeter. Now perimeter is the length around. I could add up all the sides. If you're going to do it that way, don't forget a side. So we have a side right here of 4 and a side right here of 3. And we could do 3 plus 4 plus 3 plus 4. So we get 7 plus 7. We get a perimeter of 14. But we do here. It's going to be twice the width. So we could do 2 times 3 plus 2 times 4. So we get 6 plus 8.
Which equals 14?
Which is 14. You want to find perimeters the fastest way that you can. So let's do a perimeter and an area where we have a chunk taken out. of our shape.
No, put that one.
Okay, so I have not given you all the sides, so we're going to have to think about this in a couple different, and there's a few different ways that we can think of it. This is one way. Yes, Jacob?
Well, I was just going to explain it, but
Okay, go ahead.
well, you would. I just would always divide it up, so making that a square, and
Well, it's close to a square, but yep.
and then you can see that the longer side, I would make a difference that it would be it's 3 plus 2, so 5.
So this side's 5.
Yes, and then for the rectangle, all that would be 12.
Well, this is not 12.
Well,
That's 8.
Sorry, never mind. 8.
We are going to need this side, though. It's 8.
Yes.
We need to use the other sides. Now, just by raise of hands, does anyone not understand how Jacob got this 5 right here?
I understand how you got that, but how did you get the A?
Okay, well, if this whole side is 12, and this piece is 4, and none of these are slanted,
okay, I see.
then by 12 minus 4, this side would have to be 8. Now, if they're slanted, then you can't do it that way. Alright, so now for perimeter, I don't have a perimeter formula, but because we have the definition of perimeter as being the length around, I'm going to take my 5, plus my 4, plus my 3, plus the 8, plus the 2, plus the 12, and get,
Whatever splits
34.
I'll trust that it is actually 34. Now, if I want the area, I have two pieces of this, right? So I'm going to have to find two areas. So I have base times height, and if we do this one, that's going to be my 4 times 3, so I get 12. So this piece right here has an area of 12, and this piece right here, I need a base times height. Well, this would be my base, and this would be my height, so base times height will be 24. And what do I do with those? I need to add them. So my area total is going to be 36.
So you don't mess with the 8 or the 5?
Area is base times height.
Right.
So I identify the base. The base is 12. I identify my height. The height is 2. This is not the actual length of this bottom.
Okay.
It is one of the sides, that's true, but it is not the base or the height of either of the shapes. Now, there are alternate ways to do this. I could do 5 times 12 and get like this whole big box and subtract from it this piece that's cut out here. So there's several different ways to look at it depending. Let's do another one. Okay, so we're going to find the shaded region, the area of it. So we'll find the area of the shaded part.
You didn't find the perimeter runs in the shape, but
I do not need perimeter because I'm asked for area. Okay? Yes, this is a 7 right there on the smaller one. So I have this spot in the middle that is not shaded in, so I don't want that piece. So I'm going to find the area of the entire thing. So if I find the area of this part right here, that's actually going to be including this piece in the middle. So I have base times height, and I do 10 times 6, and I get 60. That's the whole thing, including the middle. I need to take the middle out. So let's find the area of that. That's base times height, 7 times 3, which, yes, is 21. And then, any idea, what do I do? I subtract them, right? Because this is like a chunk is taken out. So I take it away, and I get 39 as the total area. And this should be units squared. I am being lazy there. Whatever the units are, if it's inches squared. If it's centimeters squared. And there's a very easy reason why. Let's say it was centimeters. and I'll just explain it this one. I'm literally doing centimeters, 10 centimeters times 6 centimeters. Centimeters times centimeters is centimeters squared. Okay, just like x times x is x squared. Just the same concept. Any questions on area or perimeter of boxes? Anyone not understand how to find the perimeter of a box or area of a box?
Joking.
Okay. We're about to, I don't know, go crazy. All right, so now let's do a circle. Now later in the year, I will give you a detailed explanation about why this formula works, but for now, we're just going to memorize it. So the perimeter of a circle is often called, anyone remember?
Circumference.
Yes. So it means the same thing. Circumference. So if you see that word, get used to talking in math speak. So that, as in, so that when you read directions on test quizzes, SAT, ACT, you understand the mathematical language. You can't ask questions during those types of tests. Or you can try, but you're not going to get answers. Get used to using math language. So, perimeter circumference, the circumference of a circle. We are going to use only this formula, C equals pi d.
We talked about that.
For the circumference. We'll use radius for area. Now we could replace diameter with 2r, and then we get circumference as 2 pi r, but often that gets confused with the area formula, so we don't want to do that. So we do want to remember this relationship. A diameter is twice the radius. Diameter is twice the radius. So d equals 2r. Or r equals d divided by 2. If you don't see that, see me later. We can talk about it. All right, so circumference is going to be pi d. Pi is the relationship of the diameter to the circumference. It is about, we can, if we're in fractions, we'll use, is it 24 over 7? I forget. Do that on your calculators. What's 24 over 7? Actually, we don't use that very much, so give me the decimal of that.
3.42.
3.17. Do 22 divided by 7.
I thought.
Just do what I asked, please.
That's it.
3.142.
It's 22.
Yeah.
Okay, thank you. All right, so it's 22 over 7, and as a decimal, about 3.14. Your calculator does have a pi button on it that gives you lots of decimal places. When your book says to estimate pi, actually do not use that button because it's going to give you a more accurate answer than your book does, and it's going to throw off your answers by a little bit. So just for ease, we'll just agree that if we're in fractions, we use this one, and if we're in decimals, we use this one. And sometimes we want an exact answer. So let's go ahead and do an example. And actually, let's get our area formula. Area of a circle is pi radius squared. So these should be formulas that you've seen before at some point. So if I give you this circle, and that's the diameter, remember diameter goes through the center. And let's say this diameter, this whole length here, let's say that is 8. So let's find the circumference and the area. So circumference is going to be pi d. So circumference is going to be, d is 8. So I have pi times 8. And I just am going to put this in the right order. That is 8 pi. If I want an estimate, I'm going to replace the 8 with 3.14.
Pi?
Yeah, I mean the pi. Thank you. I'll replace the pi with 3.14 and get, with our calculators, about
25.1.
We'll keep 2 decimal places unless we are told to round. All right, so area is going to be pi times the radius. Now what's the radius? 4. Half the diameter. And use the order of operations. 4 squared is 16, so I have 16 pi. This is the exact answer. The estimated answer is going to be 16 times 3.14, which is approximately, give me 2 decimal places, 50.24. 50.24.
For the circumference one, I did exactly what you did there. Maybe I fell into the trap of where you're...
Okay, someone, let's verify. What's 3.14 times 8? You have calculator, so we should not be getting this wrong.
50.24.
50.24. Wait,
I got it 25.12. Same.
thank you. Okay, so 25.12 was the correct answer right here. All right, going on. Going on. Okay, let's do another example, and hopefully any questions will be answered through this other example. So let's say this is 7. So what is this that I drew?
Radius.
A radius. So that's a radius. Let's say I want to find circumference and area. What's our formula for circumference that we're going to use? Pi d. What is the diameter?
14.
14. So I have 14 pi. This is the exact answer. Sometimes your book asks you for the exact answer. If it does, you're done. Yay. Don't do anything else. Sometimes we're asked for an estimate. Or it'll say use a certain number for pi. So let's use 3.14.
43.96.
And on our calculators, I am trusting. I don't have a calculator in my hand. So if you're going to put it on my your
I'm the
calculator,
one to
please
get it wrong.
type it correctly. So what's 3.14 times 14?
43.96.
Yep.
43.96 in whatever units we are in.
Mr.
It has
Kane.
fates in them.
Okay? Area. What's our formula?
Pi r squared.
Pi r squared. And we'll put in our r is 7, and 7 squared is 49. And we have 49 pi. That's our exact answer. If we are asked for the exact answer, we are done. All right? So we put in 3.14, and what is that once again?
153.86.
Gotcha. That's our approximate answer. And let's take note, I'm kind of scribbling that up there and it's not good. Okay, so equals we're going to use for exact. We're going to use this symbol, which is wavy. I'm not writing it very good. That means approximately. Okay, so whenever we use 3.14 or 22/7, that's going to be our approximation for the answer. So if you do any rounding, you shouldn't use an equal sign, you should use the approximately symbol. Let's see here. I think that is everything. Let me give you two more examples. I want you to find the area and perimeter. Yes?
So find what again?
Area and perimeter. I'll work slowly as you work on them. Occasionally check up, see if you're doing it correct. Any questions on the first one? This one was kind of tricky to divide up. Because
Yeah, how'd you get 44?
Yeah,
This side is 11.
it's 9. Yes.
Would you listen? And then if there's a mistake in my thing, we can talk. This length is 4 right here. So this length is 4. If this whole thing is 4, then what must this be? 4. So 4 times 11 would be 44. Don't be too quick to correct me. All right, area of this is, listen, pi r squared. We are not doing a good job listening today. What is the radius of this? Use your calculators. 9.3 what?
Squared.
No, we do not do 9.3 squared. I need the radius again.
Oh,
for listening.
4.65.
The radius is going to be half 9.3.
4.65.
So we're going to square that, and we can get that pretty exact. So what's 4.65 squared?
$21.62.
And then for, you probably rounded that. Did you round that?
Yes, I did.
Okay, so that should have been an approximately okay. And then let's put in pi.
67.89.
Is that correct?
Yes, sir.
67 point what?
89.
Okay. And the circumference is pi d. So pi times 9.3. So our exact answer is 9.3 pi. And we'll replace pi with 3.14 and get
29.20.
29.20. Sounds good.
Yay.
Okay, let's stop right there. I'll lose them. Just get out what I've asked for.